Hi, in this segment we're going to talk about work holding. Whenever we're milling something, it has to be held very stable. One of the things we have to make sure that it's held well enough so it doesn't go flying across the room, obviously. We want to hold it well enough in enough places so we don't get a chatter. We don't get a vibration that can cause it to get chatter marks or even in some cases break a tool. And then the other thing is that we don't want to clamp something in such a way that it would be distorted, and such that if you distort an item, when you get done machining it, flat parts won't be flat, that sort of thing. And in fact, some of the distortions you can cause can become permanent bends in the material, so that's not a good thing. So let's get started. All right, well, the first simplest type of things, clamping, is just simply clamping it in a vise. But as you can see here, this particular piece is kind of far down in the vise. It might be kind of hard to get a good, if we're going to mill this edge, for instance, it might be a little too deep. So we use parallels. These are parallels. We have a set of parallels. And parallels are, as you would imagine, these two pieces are ground together. They're very, very precise as far as their parallelism goes. I can set it in there, and we can put it on there, tighten it down good. The process of tightening, it's a good idea to take the mallet and knock it down a bit. The parallels, if things are good and your bottom piece here is nice and flat, both parallels should be tight. Now in this case, this parallel is tight, this one's not, so it just means that this edge is not really at a right angle to this edge. It's not perpendicular to it, so had a little bit of error. But also remember that this edge back here and the bottom of the vise down here are your two reference surfaces. This surface can actually move around. It does slightly, I mean ever so slightly, but it does slightly. But in case if I was going to mill this edge, this would be the good way to go. Now, again, this particular one, if I want to mill the top, I might want to bring up a little bit more than that. So I'll go to another set of parallels, a little bit higher pair. Again, tap it down. Now I can mill this surface and not worry about hitting the vise. These vise jaws are hardened, and you don't want to hit them with a tool. They are a reference surface, so obviously if you damage those, you can make it difficult for further use to get them straight. Anyway, so now this could be fly cut, and that'd be nice and accurate. And since it's referenced to parallel, it'll be parallel with the surface of the milling machine. Let's suppose we have a situation where you have a couple pieces, maybe several pieces. Could be you want to stack them up and machine them all at once. Maybe you want a whole bunch of pieces, drill them all, so be match drill them so they'll all be drilled in the same place, something along those lines. And so you put them in the vise jaws, and tighten her up. It ought to be pretty good, but even though these two bars were cut out of the same piece of steel, they vary on just enough so it won't catch. See, I can tighten this down, won't make a difference. Even a half a thousandth is just too loose. So in this case, what we'll do is open up the vise a bit. We've got a piece of wood. This piece of hardwood. Hardwood is best. Wood would work. To have the grain direction go vertical. If you put it this way, the wood might split. I'm going to put it back here, and the wood will be just resilient enough to be able to grab both pieces, kind of like form around them, so to speak. And see, and tighten the vise good, and nothing moves. See, very solid. Now, of course, the best way to machine multiple parts would be to actually put them this way and let the vise crush them together. And you can do that. I mean, if you have, well, let's say here's another piece of steel that's similar. Here's another piece. And so you could stack all these together. But sometimes this is just impossible. But sometimes you have several smaller, thinner pieces that you want to machine in this way to make them all the same size or whatever. But the problem is that if you try to put them in there with this, and you'll see what I'm talking about here in just a second. Whoa, that one drops. There's no reference for the bottom of this one. So what do we need to do? Well, let's find a parallel that's a little bit narrower than these stacked together. Here's one. It gets a little tricky. Sometimes you might want to space these out, using a magnet to make this a little easier on you. But see, I set that in there. Of course, this is too high at a mill, but you get the idea. Now they're all held well, and they're all referenced to this parallel, which is referenced to the floor of the vise, which is referenced to the tabletop. So that looks pretty good. One of the things about holding things in the vise here is that sometimes you want to be able to do several operations, or do operations on several parts and bring them all to the same location. And we've got a couple ways of doing that. This little device right here is a shop-made stop. And you can see down here there's a T-bolt or T-nut arrangement and a bolt. And we can adjust the height. For this, use a 9/64 wrench. So we adjust the height, and that's probably pretty good. Let's see, if we're going to set it for this piece, we might want to do something like this. And use a 7/8 wrench to tighten that down. Everything's tight. Now what we do is we'd oops. Tighten this down. Move our workpiece up against it and tighten it down, and then determine, you might want to measure off this point, for instance. If you're trying to make a bunch of parts the same length, measure off here, and then you can come over here and make them. But that's a good way of doing it. This is particularly good for long parts or for unusual parts, that sort of thing. For a quickie thing, this particular Kurt vise has a nice feature, and I'll slide this out of the way, release this, and this works well for shorter parts. Let's use a 5/64 wrench, and up here in the front of the vise, you'll find this little stop, and it has a tapered wedge kind of arrangement there. It fits right there in those slots. So what you can do is put that in there, get your height, at least the right height, but then just bring it in there and come up against it, and you can do many parts at the same time. Obviously, this will be for shorter parts, but quite often that's a little more convenient than going to use this. Make sure when you get done using this to put it back where it belongs. Again, let's use a 5/64. And put it back here in the front of the vise, out of harm's way. There's a little slot in front of the vise. And so that's a good way of indexing your parts to make sure you can do multiple parts and all be the same size. Now let's look at holding round work. Suppose I wanted to, let's say, drill a hole in this and put a cotter key. Something like that, to machine this thing. A good way to do that is use the V-blocks. The V-blocks have two V's. There's a larger one, a smaller one. And these are great for holding round stuff. Now, let me say that this thing is not for use to hold something in the milling machine. It's not strong enough. It's just what it's intended to be used for is to hold things while you measure them, say like on a surface plate or something like that. But don't use these for milling. Instead, set up something like this. We'll put a V-block back here. These are V-blocks are grounded as a pair, so they're very precise. Lay it in the V and clamp it in like this. Now if you wanted to, you could use some parallels underneath there, lift them up, but that holds it very securely and prevent it from rotating on you, anything like that. And very accurate, it'll hold it very straight. Now, suppose it's not a horizontal object. Maybe we want to work on the end of this particular round piece right here. Oh, still, V-block is great. We're going to use a bigger end this time and just clamp it like this. We could clamp it like this. But what can happen? Well, this can actually roll. So try it like this. It's much better. This, and this can be either on this side or this side. You know, I don't think it matters a whole lot. And you can put parallels underneath this to lift it up if you need to be. And then lock it in place, and then you can do your milling operations on the end of that round piece. And this V-block, since if you got it down good onto the surface, on this lower surface of the floor of the vise here, it will hold this very accurately vertically. So, but that's basically how you deal with round things. Now, let's talk about another way of holding round pieces, and that's collet blocks. Now, we have a set of 5C collets. The 5C collets are, we have a set of, what is it, about 18, and they make more. They make 5C collets, and actually with the hex holes in them, and square holes as well as the round ones we have. 5C collets are generally used in a lathe, but our lathe is a little small to operate, to use 5C collets in, but they still come in handy here in a milling machine. The way we use the 5C collets is with a collet block. And here's the collet block set. It's made up of 2 collet blocks, a square one and hex one, and you get a couple nuts like this which hold the collet in, and also there's a quick release mechanism which may be useful. I don't know, I haven't used that too much. Give you an example here. Let's use the square one first. So I'll put the collet in there. Note the collet has a index line in it, groove cut in it, so it has to line up with this little pin. And push it in place. Put the nut on there, just loosely right now. Then put your workpiece in there. You can bring it either from the front or back. And then you extend whatever you need coming out of here. If you're gonna, just drill a hole, that's fine, whatever. And then before you use it, be sure to tighten that nut. And I usually put the milling machine just some convenient angle like this, and tighten it up. So I want it pretty tight. And then I can index this up against the side, or I could use a little stop back here, or I could use the shop-made stop and lock it down. I'd measure to the top of my piece or determine the center of the piece and do my machining operation. Now, if we're going to make a square drive, for instance, we would cut across there with an end mill, and then we could rotate, set up same distance, cut it across again, and so on. Make sure you keep this flat. Now, sometimes it might be helpful to lay a parallel in there. Just, yeah, that's a good size. So that will help you out too, as far as getting it so it doesn't tilt on you. And then another interesting thing is that we said we get 2 sides, right? Or we could get 4 sides by rotating this 4 times. We can also get 8. So if we use our, I'm going to put this back in there. Put a V block in there, and use this on this edge. I guess I didn't do that. I'm sorry. But, first one's always the toughest, huh? There we go. Now, using a V-block like this, we can actually create 45-degree divisions. A little trick here, but and remember, and when we do this, the center distance changes. So if you've cut some using it down like this, make sure that you remeasure when you start making these cuts up here. Again, just let that thing sit down against the bottom of the vise and you'll be just fine. Now let's see, let's try the hex block. Sometimes we get hexes cut, and pretty common with model makers. You may have to make bolts, for instance, to match the scale of the model you're working on. And they may be difficult to purchase, so you just make your own. And we'll take this apart. Use the soft end, pop that out. And here's the hex collet block. Again, we have a pin. This needs to be set up. One goes a little easier. And same thing here. So we can make 6 divisions. There's different schools of thought on this. Some people prefer mounting it in the vise like this. Some people prefer mounting it like this. Sometimes, again, this helps out. Maybe your decision. It's probably a little more secure in the first method, but and if you use a combination of both of these, you can get not only 6 positions, you can actually get 12. So that's pretty neat. Anyway, that's the collet blocks. You'll find that they're very handy to use. All right, sometimes you want to be able to use angle blocks. We have some 45-degree, 90-degree type things. This is a 60-30. And say if we wanted to machine this sort of thing, that's not a problem. We put the angle block in there. Angle blocks tend to, make sure that when you put the angle block in there, make sure it bridges both sides of the vise down here so you get the correct angle. And these things tend to slide around a bit, so usually I'll put a magnet in there. That'll help keep it from sliding. And just put your piece of material in there. That should work pretty well. Now, if you haven't to deal with a thinner piece of material, then I suggest is something, maybe something like this. Well, the angle block is quite thick, so you can do it with, let's say, take just a piece of material. This probably not the best piece right here, but just make you a little shim go between it and the vise. That will hold your piece pretty well. Now, obviously, this isn't as good as we'd like. It might get a little vibration up here, but it'll do the job if you take it easy. But this is the way, we don't have them right now, but we'll probably get some angle plates there's small angle plates in there. Like you get 1 degree, 2 degree, 5 degree, that sort of thing. and you can add them together to make different sizes. And we'll use the same approach on that. So that's a good way of using the angle lock. Again, still here in the vise. All right, suppose we have something like this and we have to drill holes in the end. That can be kind of a problem, especially if we have to do some machining on the end. How do we hold that very well? And we have to lower the tail a bunch. So instead, find a good heavy piece of material, steel, aluminum, whatever. If you're just doing drilling, you could probably get by with a nice piece of wood and lock it in the vise. And I'm going to just set that on the plastic protection thing, that's fine. And we'll hold it with it and just simply hold it with a couple C-clamps. The all metal type C-clamps are the best. And if it's very critical work, you may want to indicate on this to make sure that it's true with the mill. But for the most part, this works quite well, and it gives you a few more inches, and it grabs up higher. If I had to do machining on this, like if I had to cut a cavity or something in the end of this plate, I might want a much heavier piece of material here to support it, and pretty good sized clamps. But anyway, that's a good way of doing that, and you can use the table as a reference, square reference, if this bottom edge of your piece is square.